Hi, my name's Doug. This is another Emerald Hills Skylet. In this video, we're going to compare shooting long exposures versus short exposures for a dim target. So let's get started. First, before we get too deeply, I'd like to invite you, if you like videos like this, please feel free to subscribe, maybe click a thumbs up. It does help get the channel out to other folks, as you know, and doesn't cost you anything either, but we hope it gets the word out about Electronically Assisted Astronomy, or EAA. Okay, let's dive in. We've got our new favorite planetarium program, Starry Night Pro, set up here in front of us. You can see we've got our target, our telescope aimed at a target here just above Cassiopeia. And for orientation, here's the Big Dipper, Ursa Major. You can see those two pointer stars shooting through the North Star Polaris, and then off to the left you can see Cassiopeia, and there's our target. And the target is the Heart Nebula, and the Heart Nebula is kind of a dim target. It's not very bright, and this is the kind of target I wanted to pick for this Emerald Hills Skylet. Now, in the picture here on the screen, you can see it makes a beautiful picture, but this kind of picture would take maybe 7 hours of integration to be able to see. It would be true astrophotography. So I was curious, for EAA, is it better to take a lot of short exposures or a lot of longer medium exposures if you just had, say, 6 minutes? So let's go over to our Sharp Cap setup, and we've got this Heart Nebula already tuned here in the scope. We've got our name up here. So let's start live stacking, and we'll clear the last live stack. And we've got our exposure set on 30 seconds at a gain of 100. And this is the long exposure part. What's it going to be like to do longer exposures, at least long for EAA compared? What's it going to be like to do several long exposures as compared to a bunch of short ones? So you can see our first exposure has just come in. We'll do a quick color balance. I've been seeing a lot of blues tonight. I'm not sure why, so I'm going to back down the blue just to maybe 0.11 under where the color balance recommended. In fact, looking at those curves, I'm actually going to take it down to about 0.4 under. Now let's bring our black level down just here at the crest. In fact, let's bring it down to 0.7 under. Let's bring our black level down to where we see that crest. Now let's start pushing our mids over, and you can see the interior of the Heart Nebula there. Let's bring our greens down also, maybe not as much as we did the blues, but it's not uncommon that I would have to do that. Okay, we're on our third exposure of 30 seconds. You can already see the Heart Nebula forming up. Of course, this is that brighter core. And in the Heart Nebula, it's not uncommon that that brighter core shows up better. But here is the beginning of being able to see the heart. If you can think about the Valentine heart, that's the beginning of that top of that V. And so it's already beginning to show up, even though it's a very, very dim target, at 90 seconds. So there's the fourth frame at 30 seconds each. So that's 2 minutes so far. Now, while that's forming a little bit more, let's again get an idea of where we are. This is our this is a RASA 11 that we're using. And can you see? Yeah, I think you can see there in your lower right that picture of the scope outside. That's the real-time picture of the scope. And then you can also see now in your frame a real-time picture through a ZWO ASI 178 mm, a monochrome camera with that all-sky lens attached. So we're seeing a pretty wide view of the screen. And you can see real-time here. Here's the Big Dipper Ursa Major. It's coming down through the pole star. There's the North Star coming around here to the Little Dipper Ursa Minor. And then if you go over here, you can just see the beginnings of Cassiopeia down here. So our target is up in here. That's where we're aiming. Let's go over to our planetarium program. And Again, you got to minimize what's in front of Starry Night Pro. Let's look at this target and see what they tell us, perhaps, for the apparent magnitude. They've got it as a non-naked eye target. You can't see this with your naked eye. Apparent magnitude is 6.5, and that magnitude is probably averaged out to this entire object. And if you stop and think about it, this object is pretty wide. It's 1 degree. That's pretty wide for typical targets like we might view in EAA. So if you spread out a 6.8 or whatever object across a full degree, that averages it out and makes it a pretty dim target in the night sky. So it's not really a surprise that this would be dim for us. Let's go back over to SharpCap and see this thing forming up. Now we're at 4 minutes, so 8 frames, 30 seconds each. And again, you can start to see now the rim around the outside of the heart. Of course, that bright core kind of reminds you of that E.T. episode where inside of E.T.'s heart, it's kind of pulsing. You can see that brighter inside. Well, that's kind of what I think of when I see this heart nebula. It's a very dim target, and to be honest, I think it's difficult to pull out. This is a RASA 11-inch, and so it's imaging at f2, f2.2. It's quite a dim target. We'll go ahead and push the auto stretching here. You can start to see those pinks now. Let's pull that black level just in front of that crest, and then let's bring our mids over to push those pinks a little bit more. Now you can see the full impression of the heart. We've got 2 more frames we're going to bring in, and then we're going to compare it. Before this video, before we live streamed this, I shot 6 minutes of integration at 3 seconds each. So we were shooting 3-second exposures, one after another, and we did that for a full 6 minutes. And we'll be able to compare side by side now, shooting 30-second exposures back to back, and that was 5 minutes and 30 seconds. So we're going to get ready to save here. We're shooting 30-second exposures now, and notice our gain is a lot lower at 30 seconds. We can come down to 100, which at the ASI, at this particular camera is an ASI 2600 MC Pro, and it loves a gain of 100. It's kind of its preferred gain. There we are at 6 minutes. So let's save exactly a scene so we get this picture and can make a good comparison. Now let's go ahead and stop the live stack, and now let's bring up that picture. So we're going to go to our place where SharpCap is storing these. We're going to go down to 1805, and we're going to look for the one that's 12 frames. And so there's our picture with 12 frames, 30 seconds each. Now let's go look at our picture that we shot with the gain at, I think the gain was at 300, and we were shooting 3-second frames. I'm trying to make this smaller here. Let's grab this corner so we can get a side-by-side comparison here as best we can. Get my frame set up here. Okay, so again, on the right-hand side, you can see the grain is a lot more noticeable. We're seeing all those filaments of how dirty that image is because our gain was pushed up to 300, and we only had 6 minutes of integration to be able to get rid of that grain with averaging these EAA frames. Now look at the picture on the left, and you can see that there essentially is no grain in this image. It is zero grain with the gain at 100. Now at 30 seconds, another thing we did is we picked out some of the softer reds. When I'm comparing here apples to apples, look inside of this whole dark nebula here, and look at this dark nebula. On the right hand side, you can just barely see that shade of pink, but on the left hand side, the 30-second image brought out that pink better. Now on the right hand side, for some reason, this inner bright core seems a little bit brighter red, but on the other hand, at 30 seconds, this core seems a little bit brighter pink. Now on the right hand side, I made sure that I tuned the blues down, and I think that's, oh, I just switched image there because I had this window up here. Let's go back to our other. That's the 12 frame image. I tell you what, if I'm going to compare the two, I think I don't mind the images at 30 seconds. Here's the 126 frames. So here's the image at 3 seconds. And you tell me which one you prefer. Of course, I realize you're looking at it on YouTube, but which do you prefer? What's your pick? I think on the 30-second view, the reds are more muted, aren't they? Look at these reds. They're just screaming. Of course, that could be a little bit of a color balancing issue. On this 30-second version at 6 minutes, the reds are more muted and almost a salmon, you know. On the right-hand side with that 3-second version, rapid fire 3-second images, I just don't prefer the grain very much. So with this camera, the ASI 2600 MC Pro, I kind of like shooting at 20 or 30 seconds, I think, and shooting for 6 minutes. And even with a very dim target like this, we're able to make out the full scope of the nebulosity. Let's go back now to the image that was shot in that we see in Starry Night Pro that the folks at Simulation Curriculum chose to use. They chose to use an image that was less hydrogen alpha red. They chose this more muted salmon, and for whatever reason, I don't know. But I tell you what, I think for my purposes, I'm going to like the 20-second or the 30-second version shot for 6 minutes on a dim target like this. You make up your mind. I'd like to hear your comments below when you watch this video. Which do you prefer? And maybe give us your feedback, and also tell us, when you shoot EAA, Electronically Assisted Astronomy, do you use those rapid fire 3-second images, or do you like the 20 to 30-second images? Let us know, and we'll look forward to hearing from you. This has been another Emerald Hills Skylet. We're shooting from the outskirts of Louisville, Kentucky on a moonless night at 25 degrees. And we're inside here with the scope out in the field where it's 25. And inside here it's nice and 72. We'll look forward to seeing you another time. Stop back by, and thanks for being a part of this live stream. Good night. God bless.